So this video is going to serve as an introduction for Algebra 2, Chapter 1, Section 5. And in this section, we will be graphing linear inequalities. So let's go back to the good old days of middle school math. We know that if we are graphing less than, or if we are graphing greater than, it would be an open circle on our number line. And if we were graphing greater than or equal to, or less than or equal to, that would be a circle that was shaded in on our number line. Much like this, today when you're graphing a linear equation, it won't be just graphing on a number line, which is like graphing on the x-axis. You will be graphing an actual line on the xy coordinate plane. So to show that the line is not included in our answer, we'll be using a dashed line, just like we use an open circle. And if our line is included in our answer, we'll be using a solid line to show that it's included. Now every time you end up graphing a line, let's say we're graphing the line y is greater than x plus 1. That graph's going to look something like this. It's hard for me to do a dashed line. There, that's a little better. And now we need to decide on which side of this line do our answers lie. And for that, I like to always pick the point 0, 0. Unless our line is too close to it, then you can pick any point. So if we choose 0, 0, and we're going to plug this in to see if it's true, then x is 0 and y is 0. So y is 0, and we're asking, is 0 greater than 0 plus 1? In other words, is 0 greater than 1? No, that's not. So what that means is all of our answers will lie on the side opposite, which would be over here. And just to show you what that means, let's say I pick the point negative 2, 2. So right about here, negative 2, 2. If we plug negative 2, 2 into our original, we get 2 is greater than negative 2 plus 1. So 2 is greater than negative 1, and that's a true statement. So we could pick any point in this shaded area, and it would work as a solution. Okay, let's just review rather quickly graphing lines. So let's say if I have a line y equals 1, then we're graphing everywhere on the graph where y equals 1, which is here, 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 here. And y equals 1 even in this direction. And eventually what's going to happen, all those dots will touch each other and you'll have a line, which is a horizontal line. So likewise, when we're graphing something like x equals 1, our graph will look something like this. Here's 1, x is 1 here, 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 and so on and so forth, till all those dots touch, boom, boom. And we have a horizontal line. Now, some graphs will be in the form y equals mx plus b. So in this case, m is 3 over 1, which means we go up 3, right 1 from our y-intercept, and our y-intercept is 1. So you graph your y-intercept right here, and from there you go up 1, 2, 3 over 1, and there's that line. And finally, this is one that might be a refresher. Let's say I have x plus 2y equals 4. For this one, it's much quicker to graph instead of, well, this one's easy to solve for y, but to put in 0, you're looking for your intercepts. So let's put in 0 for x. We get 0 plus 2y equals 4, which means y equals 2. So that point would be where x equals 0, y equals 2, so that's our y-intercept. Now we'll let y equals 0, so x plus 2 times 0 is nothing. So you know what, I don't even need that plus sign. So x equals 4. So 1, 2, 3, 4. Those are 2 points. And there's